later, but give you an introduction. We don't have mainly we use it in air conditioning, aquaculture, in drying, hot water spring, greenhouse. We will see about this later. So let's deep dive. It's gonna be different here. Let's see how really is happening. This how is really they're trapping the heat. So the first thing is we get this geothermal energy. The first one is from the decay of radioactive nuclei that are embedded within the earth. There are decay of radioactive nuclei which are embedded down there. This one, the first reason, that's why we are getting hotter temperature. The second one is from residual heat left over from Earth's formation, which is not yet utilized according the science. According the science says. And the third one, the rest of energy comes from meteorite impacts. So these are the three things why we are getting heat from the earth that we are living, especially from starting from the core up to the crust. So if you think this is the earth that we have, you can say the heat generated from the earth's core. Here the heat generated from the earth's core, we call it geothermal energy. We don't have the crust here and we don't have the core here, right? So the magma is, and rock is right here. So this is heating the water and the rock above. So we can use it for power plant purpose or for industrial applications, so any kind of generating electricity. So we have different geothermal resources. Like they do use all reservoirs. They don't have reservoirs, all of them, but the way they give us the energy is different. This one is in hot water, this one is in natural steam, and this one is in geopressurized form. So the question is, how does the system work? So we need to answer this question. How does this geothermal work? The first one is direct source function by sending water down a wall or a pool to be heated by the earth's warmth. Let's say this is the surface that we are living now. Let's say this is beneath the surface, which we call it cubic crust or something. So first thing that we do is we send this water down a wall to be heated by. We just pour the water here. Let's say if it is the wall, and then the next one is after it gets hotter, or after it becomes hot, we use a heat pump to take the heat from the underground. To take the heat, we use heat pump here to take the water or the heat from the underground to the substance that heats the house. The substance that heats the house. It could be house or it could be any kind of purpose, but we take that thing. Then the last thing is, then after the water is cold and ejected back into the earth. After the water right here is cold, we then send it for the second time to this underground area. So we just repeat this process so many times again and again in order to have non-stop power output. Let me make it clear here. So this is geothermal power plant, right? So first thing is we have injection wall here. Injection wall. First we inject this water right here. After it gets hotter, we have a heat pump here. So we need to extract it here and convert it into steam. So in a steam form, it can drive a turbine, right? So this turbine is attached into a generator. So we have a tower here, right? So using this tower, we can have a power output, which can be used in the city or in any kind of purpose, which we need an electricity generation. And the other thing is the water comes here, so the cooled water or we don't have cooling tower, and then it's sent to the underground. This process is repeated so many times in order to have a constant power output. So what are the application of? The first one is we can use for space heating, we can use it for air conditioning and for drying purpose, for greenhouse gas, for aquaculture, hot water, so many melting snow, so many applications. You can go and read for those things if you want. So what are the advantages?